In the last episode, we wired ROVer up with the IR receiver.
Good afternoon.
Good afternoon, ROVer. And proved that we could make that work with the Apple TV remote, whereby the Arduino Uno was passing that information over to the Mega, up to the Android tablet, and over to the web server in the cloud, and we could review that information in the command center. And the next step was for me to actually make that useful. That's what we're going to do today. So we're going to start with a short drive command. I'll send over to ROVer by the command center. And then I'm going to execute an emergency stop by pressing the play pause button. And then we'll take a look at the command center to see how that information has been relayed over to the cloud. So here we go with the drive command. ROVer's initiating, he's starting to roll, play pause, and he stopped. He's now reading over the information to the web server, so we'll do a couple of refreshes here. And we see the information percolating up. And there we have it. We've got a drive command issued from the web server, and we've got ROVer reporting that he received an Apple play pause signal, which he interpreted as all stop. And then he powered off the roboclaws. And three of these were logs sent from ROVer. So what we saw there was pretty cool, and I'm glad that it all works, but that's really kind of the most basic example of how we can make use of this. You'll remember that in the previous episode, I talked about how to use the what appears to be limited 7-button remote in many more ways than you would imagine. And that depends on context. So for example, what does a play pause button press represent given what else is going on? So what we saw a moment ago was ROVer driving, and when he received the play pause command, he stopped immediately and interpreted that as an emergency stop. What we'd also like to see, for example, and I mentioned this in the previous episode, was to be able to replay a command. So let's say, for example, I just initiated the play pause and I had him do an emergency stop, and I quickly want him to resume what he was doing previously by pushing another button. Context. What I mean by that is being able to use the information he's sending to us with an appreciation of what is happening in and around him and what he's experiencing. So for example, being able to use that Apple TV play button pause for different commands depending on whether he is driving or in standby mode. If he's driving, the button press executes an emergency stop. If he's in standby mode, maybe it executes that replay command that I've been after. So in order to do that, we've needed to implement some functionality on the web server in the command center, and that's what you see here. So we've got a new function, or a new feature, I should say, for status. And as we execute commands, which I'll do right now, I'm going to send over a short drive command to ROVer. So you just heard him click on, and he's rolling. And I'm going to do a couple of refreshes here. And you see basically that the status turned to driving, and in a moment he's going to flip off. You're going to hear the relays flip, and there they go. And now if I keep doing a refresh, you'll see that the status is going to change to standby, just as it did now. I didn't realize how complicated this was going to become until I actually tried to implement it, because my thought was that we would be able to tell based on simply whether an order had been executed or not. Unfortunately, if we try that again, so I'm going to send over the same drive command over to ROVer, and I do a couple of refreshes. He's still driving right now, but the status has already appeared as executed here on the command center. So the problem is he's still in operating mode, he's still driving, but the command center didn't really have any visibility into that. So we needed a way for ROVer to communicate when he's doing something versus not doing something. So similarly, let's say if I send over a command for him to straighten out his wheels via the servos, you can hear them working. If I do a couple of refreshes here, you can see that the orders are being executed one by one, and the status has been changed to rotating. If I keep doing a refresh. All of them have been executed now, and the status has been flipped to standby. That functionality, as basic and fundamental as it might seem, was really important for the next step in terms of being able to implement that contextual interpretation of commands and information as it's coming into the web server. That, however, was only the first of several problems, which in turn revealed a whole bunch of bugs that I needed to squash before I could get to what I actually wanted to do. So if we take a look at the command center and the command that we sent over to ROVer a moment ago, we asked him to drive forward, and then we sent over the Apple TV play pause command, which had him do an emergency stop, and then he communicated that he was powering off the roboclaws. So if you notice, now those were 3 commands coming in from ROVer, or 3 logs coming in from ROVer in very quick succession. And the problem that revealed, that I didn't anticipate earlier, was in the timing of things. And basically what that necessitated was implementing some buffers, both on the Arduino side here, and then in the Android side here. So here's a quick example of how the buffer works. I'm going to send over the same drive command as per usual, and then I'm going to stop ROVer by putting my hand in front of his sensor, his forward sensor, and then he'll log all sorts of events that will fill up the buffer, and then slowly relinquish that buffer, empty the buffer as he passes that information over to the Arduino Mega board, and then onto the Android tablet and up to the web server in the cloud. So we sent over the command. I'll let ROVer get started, and then I'll block his sensor. So there he goes and stops.
Oops.
And then here,
Excuse me.
I'm going to turn off the auto scroll, and we see here that the buffer started to fill up with the 01 command, 09, 0910, and then we see the 01 has already disappeared here, and now we're down to the 09 value, the 10 value, just the 10 value, and then we're all clear. And that's basically how the buffer works. The fundamental point of this is for ROVer to be able to send information over to us as quickly as he needs to send that information, but for us to be able to process that in the time that makes sense. So keep in mind that while we want everything to percolate up to the web server in the cloud, we can't constantly be pinging the web server, every few milliseconds the way ROVer does loops on the Arduino boards. So right now we've got everything set up for a 2-second loop on the web server, and even that is a lot. So we have to, so the buffers basically allow us to mesh those two things together. The fact that the Arduino is operating very quickly, the Android is operating very quickly, but we don't necessarily want the communication between ROVer and the web server to be as rapid. So once we had the web server understanding the context, the status of what ROVer happens to be doing at the given, in real time, then we could implement that contextual functionality that I wanted for the Apple TV remote. But the infrastructure that we're putting in place here with the buffers and the status within the command center, all of that is going to be useful for so many other things that we're going to do down the road. So what we'll do now is we'll send over the same drive command, and I'll have ROVer stop while he's driving by using the pause button on the Apple TV remote. So here we go. We're going to send over the drive command. There, ROVer's going to start rolling, and I'm going to pause him. We saw him turn off. We're going to do a refresh on the command center here. And there's all the information that percolated up. So we saw the Apple TV remote being recorded, the all stop, and then the powering off. That was all logged from ROVer over a matter of a few seconds. So now that we see in the command center that the status, so now that we see the status in the command center is in standby, that same press of the play pause button on the Apple TV remote should do something very different. So here we go again, same play pause button, but ROVer is in standby. And there he goes. We'll let him finish, and we'll do a refresh on the command center here. So we see the Apple TV remote command being recorded and logged on the command center. We see the replay being issued. So basically it's scripted such that it looks for the previous command that was executed, copies that over in a pending state, and then slowly but surely ROVer executes that command. If we do another refresh, we then see the powering off log from ROVer once he was finished with the command. And now, of course, if we scroll back up, we see he's back into standby. So I don't think Steve Jobs and Apple ever imagined the humble Apple TV remote being used as a controller for a robot, but there you have it. And the options that we now have with just these 7 buttons has grown exponentially because we understand the context within which ROVer's operating at any given time. And we understand that from the web server, from the command center and the cloud, which of course is accessible from anywhere in the world on any internet connected device. Of course, that brings us to the next thing, which is this little thing that's still dangling here, and I need a place to mount it. So with the American Thanksgiving, and more importantly, with the Black Friday and Cyber Monday coming up, it's an excellent opportunity to order some parts for ROVer at a small discount. And I want to talk to you guys a little bit about the kind of ideas that I'm brainstorming for how to build out things like how to mount ROVer's Android tablet, the solar panel array, and sensors that need to be in a different orientation than necessarily directly on the chassis. Here we've got the solar panels, as you'll recognize from a few episodes back. The middle one is mounted with the hardware from that test. And as you can see, with the array fully extended, it overlaps by about, 6 inches on either end. Here we've got the sketch from a few episodes ago that I absolutely love in terms of, well, kind of the roboticism of it all. That being said, I'm trying to figure out how to actually make it work, and some aspects are good and some aspects are not necessarily good. As you can see, lots of kind of playing around with the idea, how to go about it, how to actually make the hardware work. As you Americans will know, of course, Thanksgiving is coming up this weekend. More importantly, it's Black Friday and Cyber Monday, and it's a perfect opportunity to order the mechanical parts from various robotics type websites to actually get stuff mounted like the solar panel array and ROVer's Android tablet frame. So I really want to spend some time and focus in on exactly how to make that all work so that I can order those parts at a little bit of a discount. I don't know if you guys find this as funny as I do, but one of the aspects that I struggle with most is that basically balancing aesthetics with functionality. As much as I want ROVer to be able to do certain things, the way in which it all comes together from a prettiness perspective is actually kind of important to me as well. So that all being said, one of the key considerations is how to mount ROVer's Android tablet frame. I'm trying to think of it from the perspectives of what I would like in an ideal world, and then trying to work from that backwards in terms of how to actually make it happen. So in an ideal world, I want to have the option of the Android tablet being low and forward like this, put away somehow underneath the solar panels when I don't need it. As well, it would be awesome if we had a way by which to have the Android tablet mounted higher in some scenarios where we can get a different perspective with the camera, as well as a point on which we could mount other sensors, such as the infrared receiver that we're using with the Apple TV remote. So this brought me to this sort of idea where, for example, we had an arm with multiple joints. So basically here, what I also realized was even if we want to have the pivot at the middle, it doesn't necessarily mean it has to be off the same shaft, where it's kind of cluttered with all sorts of wires coming out and everything. So we could raise that up and have the same sort of functionality. In any case, it brings me to this idea where we can have this multi-joint arm raise the tablet, for example, at the end here. But that kind of brought me to another idea. What if this arm was multi-purpose? And this is a perfect example of how my imagination gets me into trouble. You see what I mean? My imagination gets me into trouble. So I've taken one potential problem and created 10 others, because I have no idea how I could make that thing work. But the prospect of it actually coming together is incredibly cool. So from having to figure out how to mount the solar array, the Android tablet, I've now managed to even further complicate that by trying to put in a complete ARM functionality with manipulation and et cetera, et cetera. My imagination is a terrible, terrible thing. That being said, I'm kind of excited about trying to figure this stuff out. I've got somewhat of a deadline with Black Friday and Cyber Monday on the horizon. So do stay tuned, subscribe to get notified of new episodes. Use the comments down below on YouTube or over on ROVer's site. We'd love to hear from you. Any suggestions, questions, ideas, what have you. Give us a thumbs up and we'll see you guys next time. Cheers.